Hi, welcome to the Introstat lecture series. And we are in this unit, we call it the sample survey. And this is the second video for the lecture number 10 of the sampling methods here. Okay, so for the first video, we talk about what is the sampling and the three big ideas about the samplings here. And now for the second video, we're going to take a look what are the different sampling plans here, or we call the different sampling methods here. So let's go ahead and take a look at our lecture notes here. So let's try to refresh the memory from our first video. We said three big ideas about sampling. So the first idea is bias, right? So bias is the number one things we try to avoid when we take the samples. Then the second one is here, when you do a samples here, we need to randomize our procedures here. Because when you randomize your procedure, you can protect yourself against some factors. Either you can control or you cannot control here. Okay, so the next one here, we call it the sample size. That means we do know it's the sample size is actually the number of the units you sampled, right? It's not a part of the total population percent, because we know that sometimes the population is so big, right? So but if your sample is good, if your sampling method is good, you will get a good information. So in general, of course, the larger the sample size give you more accurate information. Then the other parts here will just be, the larger the sample size costs more. All right. Okay. So for this video, we're going to talk about the several different sampling methods, and those methods here are the most commonly methods here we have, we use during our samplings here. Okay, so the first one we call it is SRS. All right, that means simple random samples here. Simple random sample, what does that mean here? For the simple random sample, that means every possible group So we know every possible group of n individual, okay, has an equal chance. Has equal chance of being samples here. So the simple random sample, the keyword here is they have equal chance. So it's similar, like if I want to sample like 20 students from the university. So what I can do here is kind of like the scenario, you put every student's name in a bucket, and then you just randomly pick 20 of them. So every student's names is in the bucket. So every one of them have the equal chance to be chosen here. All right, so that's what we call this a simple random sample. And the simple random sample sometimes is very good, but sometimes, because you want to make sure everybody have the equal chance to be sampled. So sometimes it will be difficult and very time consuming here. Okay, so that's what is the simple random sample. So basically, you kind of treat it like inside this bucket, right? So inside this bucket, you have all your individuals in the populations here. Then you just randomly pick, right? So you just randomly pick a few. So like you randomly pick a few, then every one of them have the equal chance to be picked. That's what we call it, a simple random sample. Okay, stratify, what is the stratify samples here? Okay, the stratified sample, that means the first you divide, you divide your group into several subgroups here. So let's see here, right? So in here, the first things here, you sampling. So you need to identify we call this a homogeneous subgroup. Okay, and then you take a random sample within each subgroup. So imagine here, this is your whole population here. So this is how do you visualize? So you imagine this is your whole populations, right? Then within this population, the key word here you need to see is this is the homogeneous subgroup. You divide this one into a few subgroups like group 1, group 2, group 3, so group 4, right? So this is group 1, group 2, group 3, group 4. Under each subgroup, we call this a homogeneous subgroup. That means they have the same characteristics here. Right, so that's why I'm using the different colors here. So like they have the same characteristics. Okay, let me see the other ones here. Okay, so that's what we call is the homogeneous group. So for example, in the university, and you can divide the group as a freshman, sophomore, junior, and the seniors, right? Now under each one here, you will randomly pick like, so let's see here, you will randomly pick, let's see here, let me get a good color here. All right, so you will randomly pick a few samples, right? So you pick this one, yeah, this color is not very good. Let me get here, neon green. Okay, so you will randomly pick a few samples here. Right, so this type of the sampling, so just like we said, for the university student, if I want to check how they perform during this year, so I can divide the group into the freshmen, junior, sophomore, and senior. Maybe for each subgroup, like a freshman group has their own behavior, and a senior, maybe they have their own behavior. Then I take the few, I take a random sample within each group. This what we call is the, the stratified sample. And the one of the biggest okay, the advantages here. So this is the one of the big advantages here. So it will be reducing sampling variability. Okay, so the reduced sampling variability, this is the most important characteristic for the stratify. So this is the most important characteristic for the stratifies here. So think about it, if I want to choose the students from the universities, right? I take a random sample. It's possible if I just take a simple random sample, it's possible, right? Maybe the chance is small, but it's possible my sample is all from the junior. It's possible. And so then I don't cover the freshman and the senior or sophomores, right? So for this way stratify, so for each homogeneous group, I'm make sure I'm going to get the sample from that. That's why this is one we said is the most important characteristic and the most important benefit we want to get out from the stratified sampling here. All right. And then in here, the second one here, we also can, because you can reduce the sampling, then also you can help to notice. Also, it will help to notice the important differences among the group. All right. Okay, so now in here, when you want to take a look at how is the, the students' behavior on the GPA, right? So if you do a stratified sampling, you're going to see the like a freshman's group, a sophomore's group, junior, and the senior. So if there is differences, then you'll be able to identify that, right? So also that's why the second part here is to say that's the benefit also, right? Help to notice the important differences among the groups here. Okay, class sampling, right? And so the class sampling, what is the class sampling here? Cluster. And the cluster sampling here. So first things here, we're going to identify the heterogeneous group. Heterogeneous subgroup. All right. And so then you take a sample. Okay, with it, so you randomly, so that you identify the heterogeneous, so you randomly, okay, so you randomly select one or more the subgroups, right? You randomly select one or more subgroups. Let's say you can randomly select the one or more subgroups. Right, and then you do the sampling. So here, let's do a picture again, right? So this is the pictures here. Then I'm also divided into 4 groups. But now those 4 groups acting is a little bit different. So like for this group is, we call this the heterogeneous, right? So these ones here, I have maybe cover all these characteristics here. All right, so here, what is the other color? I use blues here, right? So you see here in the each group, this is what we call this the heterogeneous, right? So in here, I can have some here, some here, some here, and then in here, I have here, and then I will have some here. Okay, and the last one is green here. You see the differences between these 2 samplings here. So for these ones here, you identify the heterogeneous subgroups here. All right, then you randomly pick one, or if you have a large population, you might pick 2. So you can you randomly pick one here, right? So because this heterogeneous subgroup will cover all the different, like the freshmen, junior, sophomore, and the seniors, right? So you randomly pick ones here, and then you take the sample within these groups here. You see the colors here? So that's what we call this the heterogeneous subgroup. So for example, like the university examples here, right? So you say, okay, I want to take a sample and it's a cluster sample. So maybe instead of identify who is a freshman, junior, sophomore, what you can do is you take a sample from dorm, right? So you will say, hey, I choose this dorm, and this dorm, because from dorm to dorm, you assume they will have like they all have the freshman live there, sophomore live there, junior live there, senior live there. So you choose a dorm, and then inside that dorm, you go to ask for each person in the dorm about the survey you try to do here, right? Because the dorm is a heterogeneous groups here. So make sure you understand the differences between the stratify and the clusters, okay? So what is the most benefit for the clusters here, all right? And so the biggest benefit here is the conveniences and practicality and cost here. So this is the number 1 the benefit here, right? So this is the most important part for the clusters, the most important and the benefit for the cluster sampling is here, because then you can just randomly choose one dorm and then go inside that dorm to ask the people, instead of you choose like the cross the campus, freshman, sophomore, junior, then you need to chase them down, right? So it's so the most important part is very convenience, and it's practical, and also the cost is here. Okay, and then also because of this, so when you choose here the cluster, because it is the heterogeneous, right? So the heterogeneous is here, right? So this is the, okay, so this is the heterogeneous. So that means what? The sample from the heterogeneous group, sample from the heterogeneous should represent populations, right? Right, see these pictures here. That's what we call the cluster. Okay, now the next ones here we're going to talk about is a systematic sampling. What is the systematic sampling? So basically, it's kind of like we just said a systematic sampling. That means you sampling, you select each individual. Okay, systematically. Okay, so each individual systematic. So what's that means here? Okay, so let me do a picture for you. So in here, so you say this is my populations, right? So you give each person a number, all right? So you will say, for example, this is number 1, number 2, number 3, number 4, and the number 5. And so number 6, number 7, number 8, number 10, number 9, number 10, number 11, number 12 is here. Okay, so of course, we should have more than that. I'm just trying to use examples here. So what is the systematic things here, right? So you choose one. So you randomly pick a number, all right? So you randomly pick a number. So I say, hey, I pick a number. I just randomly pick a number. I pick number 4. Okay, so this is the first number 4 I'm choosing. Then instead of just randomly picking other number, then you say, I will choose whatever the number I pick, I will choose the sample is this number plus 3. All right, so if your first number you choose is 4, so the next number you will be 7, right? Then the next person you will choose is which has number has number 10. Okay, so the key things here is, in order to avoid the bias here, what you want to do here, when you start, right? So you start sampling randomly. Okay, so like what we talked before, I will randomly pick a first numbers here. So my randomly pick the first number, this number 4, this is my starting number. So I need to randomly pick this number, right? So then I would say I add 3 numbers. Like add 3 will be my next number, add 3 will be my next numbers here. All right, so this will be what I call is the systematically. So what is the biggest benefit here? So what is the biggest benefits here is less expensive. Okay, it's less expensive sampling methods here, because as long as you just need to, pick one, and the other is very systematically, you can get it. Just like if you are waiting for a door, you said, okay, I will randomly pick a time to pick a customer, walk in the door. Then every 10th customer walking in, I will sample, right? So that's what we call this a systematic sample. Okay, so the last sampling, we call just the multi-stage samples here. So this is just like what we called. So that means your sampling methods here. So your sampling methods here that combines several methods here. Several methods together, right? And called the multi-stage samples here. So for examples here, you said, I'm choosing, I can use the cluster first, right? So for examples here, you can say, I'm choosing a dorm, all right? Choose a dorm. Okay, from many dorms, so this is a cluster. Then inside each dorm, I give numbers like 1 to 2,000. Maybe we'll have 1,000 residents live there. Then you randomly pick a number. So if you pick a number is 121, then you say every 10th. So you have 121. Then you have 131, 141, right? So this sampling is multi-sampling, multi-stage, right? So the first stage is you use the cluster, right? Then the second stage you use the systematically, right? So we call it the systematically, right? So that's why you combine like a different methods. Sometimes you can combine the 2 or 3 or 4s, right? Depends on what you want to sample here. Okay, that's it. So for this video, we talk very briefly of, we have 5 different most commonly used sampling methods here. So make sure you understand what is each sample, how they do it, and the most important one, the stratifying and the cluster, make sure you know the differences, right? And also for each sampling, the pros and the cons. What are the benefits? What could be the issues here? All right, that's it. And guess well, in the next video, we're going to talk about when we sampling, what type of the mistakes we're going to make here. All right, nice talk to you, and I'll talk to you in our next videos here. Okay, bye.